All right, so I think this is recording. Let's take a look at 4, 5, and 6 here. I didn't copy the directions, but it's asking us to find each of the compositions, F composed with G and G composed with F for each one of these problems. So for number 4, um, F composed with G of X, F of G of X, well, G is the function 5x plus 3. That's the input for F. So what does F always do to the input? F always creates a subtraction problem where the first term is the input and then it takes away 2. So this is 5x plus 3 minus 2. So we have our final answer that F composed with G of X is equal to 5x plus 1. And for G composed with F, let's replace F with x minus 2. And what does the function g do to the input? G always creates an addition problem where the first term is 5 times the input and the second term is always 3. So we distribute, combine like terms, and we have our final answer. Uh, 5x minus 10, but a negative 10 plus 3 minus 7. So there are our answers for number 4. Let's take a look at number 5. If we find F composed with G of X, G is the function x plus 1, F is the squaring function. It always takes the input no matter what it is, and it squares it. So F composed with G of X is equal to x squared plus 2x plus 1. Remember, exponents do not distribute. This is not x squared plus 1 squared. If we find G composed with F, see, I'm doing the second one. G is, no, F is x squared. What does G always do to the input? G always creates an addition problem where it takes the input and adds 1 to it. So that's our final answer, that G composed with F of X is x squared plus 1. So you can see each time we're taking F and G and we're building new functions, F composed with G and G composed with F. Oops. All right, for the last one, let's find F composed with G of X. or F composed with G. G is 3x minus 1. Well, what will F always do to the input? F always creates an addition problem. It takes the input and adds 2. So our final answer is 3x plus 1. For G composed with F, the function G always creates a subtraction problem. 3 times the input, no matter what that input is, minus 1. This time the input is x plus 2. We distribute, we get 3x plus 6, and 6 minus 1 is 5. All right, so I hope that helps. If you have any questions, ask. Let me know if I've made any silly errors in this. One time, if you caught it, when I was starting to do number 5, when I looked back up, I started to use one of the other functions. I kind of started to mix and match the two functions. That's probably one of the mistakes that I would be very likely to do in one of these videos and not catch it. So if I do something like that, please let me know, and I can either redo or edit the video. Thanks a lot. Talk to you later. Bye.